Hi, my name is Professor Illich, and I'm here to talk to you about fun with data. So this is our first discussion about statistics and why we use them and what we do with them. And so you're going to see me for a minute, and then I'm going to go just to looking at the screen, and you'll hear my voice. But I don't have any students in front of me, so it's probably not very fun to watch me stare at a camera. So let's just go ahead and get started here. This idea is that statistics is making sense out of data. Data is useless if you don't have a context. You need to know where you got all these numbers or all this information from, and you need to be careful to think about how it was collected and what the different elements of the data mean. So we often describe the context of data by the 5 W's: the who, the what, the where, the when, and sometimes the how. So a case is an individual. So here's a case is an individual about whom or which we have data. And a population is all of the cases we wish to know about. So if you have the entire population, sometimes we don't have the entire population, we just have a sample of the population. And we can make inferences. We're going to learn about that later. Inferences based on the sample. We can make some decisions or draw some conclusions perhaps about the entire population. So a variable holds information about the same characteristic for many cases. So say you have a bunch of people in the class, and a bit of the information, like even for this class, we may get everyone's age. So age would be a variable, and the student, would be a case. So if I ask for your age and for your major and for your height and weight, but I promise not to, and your eye color, if I ask those kind of things, that would be data. And on each individual, who would be a case, the population would be our entire class. I could just take a couple people if I wanted. That would be a sample. And age would be a variable, eye color would be a variable, major would be a variable. So it's information about the same characteristic for many cases. Now, the units are the quantity or amount adopted as a standard of measurement, such as dollars, hours, grams. So if I had collected information on this class, I would ask you your age. The unit there would be year. Age is actually what we call a quantitative variable, because it measures a quantity. A categorical variable, if I had collected data on the class, would be eye color. Blue, green, brown. They falls into a category. Your eye color doesn't have a unit. It's associated with it. If I asked for your income, that maybe would be in dollars. So that would be quantitative. So we have these two types of variables: categorical, where you have categories, the names categories, whether with words or numerals, and quantitative, which is a variable where numbers act as a numerical value. Quantitative variables always have the same units. Okay, so sometimes when you get data, it is arranged in a data table where a row represents a case and each column represents a variable. So this is taken, and it's an example from your textbook, and we're just going to read it. It says the 2.5-mile Indianapolis Motor Speedway has been home to a race on Memorial Day nearly every year since 1911. Even during the first race, there were controversies. Ralph Mulford was given the checkered flag first, but took 3 extra laps just to make sure he'd completed 500 miles. When he finished, another driver, Ray Herron, was being presented with the winner's trophy, and Mulford's protests were ignored. Herron averaged 74.6 miles per hour for 500 miles, but in 2003, the winner, Gil de Ferran, averaged 153.6 miles per hour. So here's the data. Here are the data for the first few and 4 recent Indianapolis 500 races, and they have the pole winners. The winner of the trial the day before, when each racer drives alone, determines the position on race day. So maybe you've seen the race. They can't all start at the beginning, so you have to kind of have like time trials to see who gets to place where. Okay, so we want to identify the five characteristics, or the 5 W's of the data. So let's see if we can figure out what the who of this data is. All right, well, the who, let me see if I can get this to insert a text box. Let me see. All right, there we go. Okay, so the who here is the Indy 500. That's the race that we're dealing with. Okay. What are we looking at? Well, we're looking at all of these different variables. So we've got pole position, average speed, a year winner, pole winner, and average pole speed. So those are all the whats. Okay, and then, sorry, I took a break there to change my font color. Okay, now the when, it looks like it occurred between 1911 and 2003. So 1911, let's see if I can get this to, I want it to stay the same color. 1911 to 2003. So we can see that. Why? Well, I don't know, to see trends in auto racing maybe? And then how do they do it? Well, statistics are taken, official stats from the race is how they created these. So we'll say that these are just going to be official stats from the race. Okay, now we're also asked to look at the variables themselves, year, winner, pole position, average speed, and decide whether they are quantitative or categorical. Well, remember, it's quantitative if it has units associated with it. So a year has a unit associated with it, and so it would for sure be quantitative. So it doesn't want to be, so I'll just keep it black. I wanted it to be red, but it doesn't want to be. Okay, the winner, now that is is going to be a category because that's someone's name, and pole winner is also going to be a category, who they are. You don't really have a unit with someone's name, but your position is going to be, because it's what position you are, your average speed and your average pole speed, those are all quantitative. So we will, I didn't spell that correctly, did I? So we will call that quantitative. They don't even like that word. Okay, that'll be quantitative as well, and I'll just copy and paste this so I don't have to type it again. So average speed is going to be quantitative, again, because it has a unit, and average pole speed is also quantitative. So this gives you a little sense. And so as you're working your first homework problems, you actually have to select, look at the situation and decide the who, the what, the when, the why, and the how, and then determine whether the variable is categorical or quantitative. So it's kind of fun and not too tricky to do. So that takes us, that's really chapter 2 in the textbooks. If you want to read in your textbook, you should go ahead and read chapter 2 to get some more examples if you're looking for it. So now I want to move on to chapter 3, and this is going to be a lot of fun because we're going to get to play in Excel a little bit. We're going to only be thinking about categorical data right now, and we want to kind of organize our categorical data, and we can do that by piling the data and in each category of interest, okay? And then we organize these counts or piles into what we call a frequency table, which records the totals and the category names. So if you look on this example, this right here is what we call a frequency table. What we're looking at here is an investigation compiled from information about recent non-military plane crashes, and this is the percent of these different causes of a plane crash. So we've kind of organized our data into what's called a frequency, or how frequent it occurred. Now this picture that they gave us is actually, they didn't give us the number of plane crashes, but they gave us the percent. So this one is actually looking at a relative frequency table because it gives us the percentage instead of the counts for each category. So for the two examples I give you, they're both percentages. So I'm giving you relative frequency tables, but that's just part out of total to get that percent. So if you were given the number, you could make it a percent by doing the number out of the total and then multiplying it by 100. Okay. Now, a bar chart is a way that you can display the distribution of categorical variables showing the counts for each category next to each other for easy comparison. And it's important when you're making displays that, you know, if you make a picture display, you want to use something like a bar because that obeys the area principle, which is that the area occupied by a part of the graph should correspond to the magnitude of the value it represents. So I don't know if you've ever seen like pictures in the newspaper or graphs in the newspaper where they have, maybe they're trying to show the number of people and they have little people to show how many people are represented in a certain group. And it's kind of cute and fun to look at, but it doesn't obey the area principle, and so it can be kind of misleading. And when you're communicating data, you want to try and be clear. So a bar chart is a really good way to stay clear. Now, on these two examples, we're actually going to be making relative frequency bar charts because we're looking at proportions or percentages because we're going to replace the counts with percentages. Sometimes you might want to make a pie chart, which is shows the whole group of the cases as a circle, and they slice the circle into pieces whose size is proportional to the fraction of the whole in the category. So these things we're all going to do. We're going to do these two examples, number 14 and number 16 from your textbook, and we're going to do them in a program called Excel. So this may be your first experience with Excel, but I want to get it up here and look at it with you. And so let me bring it over. All right, so this is Excel, and what I did is on each sheet, sheet 1, sheet 2, and then sheet 3 in a minute we'll talk about, we're going to look at these situations. Now, when you're in your online homework, you can actually click the little button in the corner and it'll grab the data if you're looking at a table and save it, and then you can paste it into your website, straight into Excel. But because I copied these out of the textbook, I'm going to have to enter the data in by hand, which is actually okay since this is the first time that we're going through this. I wanted to explain to you how it is that you kind of navigate in Excel. Notice here this is A1, which means this is a cell. These are all cells and they're all labeled by, here you can see the name of the cell is column A and then row 1. If I move over here, that's column B, row 5. Okay, and so I'm just going to type the word cause, and then I'm going to type percent. Okay, and then I'll come in and I'm going to type in the different causes. So we've got pilot error, and maybe you're following along, other human error, weather, mechanical failure, and sabotage. Okay, and then I'll go ahead and put my percents in. So I'm going to do 40%, and then 5, and then, and I'm choosing to write these as percents. You can if you want, because when you make your bar chart, you're going to want it to show that it's percentages. So 6%, 14%. And then finally sabotage is 6%. Okay, now the first thing I'd like to do in Excel is I'd like to see these. I'd like to make this column wider. And there's quite a few ways that you can do it, but kind of one of the funnest ways is just to come right up here to right where the rows are labeled, right in between. You can see those arrows, and I can just drag it to where I can, and just to where it sort of fits. Okay, so that's one way to do it. There's some other ways that you can make it work, but that's a real fun way to do it. Now, you might want to check first to see if this actually adds up to 100%. If it does add to 100%, then you know you have everything represented. If it adds up to more than 100%, it must be that there were some causes that were overlapping. Maybe it was other human error and weather. They both got counted in there, and so that was over 100%. That sometimes can happen. You have to just kind of watch out for that, because if that's the case, then a pie chart's not going to be a good choice for you, because the pie chart needs to slice up 100, and so if you have that overlapping, it's not really going to make sense. So what you want to do is you want to see what this total is, and Excel can do this for you real quickly. If you just come over here to the AutoSum button, and then and then just click the right click and just choose sum, and notice it thinks that you just want to sum those numbers, and so you just tell it yes by hitting enter, and it says that's 71%. So right away you know that there must be something that is not determined. We don't know what caused the plane crash. So let's go ahead and figure out what that number is. If you're quick with the numbers, you might recognize it's 29%, but let's see. So let's call it not determined. And then in this cell, I'm going to make a little formula. Up here, you'll notice in Excel, whenever you want to do a formula, the equal sign comes in first. This is called the formula bar. So I'm going to put a right here, and I'm going to do 100% minus that sum. And then I'll hit enter, and it'll give me the 29%. So that was kind of fun. All right, so I've got my little chart going. So let's see if we can answer these questions. It says, is it reasonable to conclude that the weather or mechanical failure caused only about 20% of the recent plane crashes? Let's see if that's reasonable. Weather and mechanical failure, if you add those together, it does 6%, and 14% is 20%. So we can answer this question by saying, yeah, it is reasonable to conclude that weather or mechanical failure caused only about 20% of the recent plane crashes. So I feel okay about that. Let's see. In what percent of the crashes were the causes not determined? Well, that's just what we just saw, the 29%, because that was the 100% minus the sum of these. And then it asks us to create an appropriate display for the data. So this is kind of fun. What you're going to do is you're going to highlight your data, and I'm going to choose to make a pie chart because I think those are kind of fun. So I'm going to go to insert because I know this adds up to 100%, so get another good reason. So I come up here to this is called the ribbon, and I chose insert, and I'm going to go to pie, and then I'll just pick this first one as kind of the simplest pie chart. And so I'll go like that, and there's a nice little answer with the data arranged as a pie chart. And you can do some different things, like you can get the percentages to show on the pie chart if you want, and you can, that kind of looks nice. I like that, to see those percentages. And then you could put a title in here, cause of plane crashes. You could come right in here and say, okay, cause of plane crash. You can put a nice title there, and you've got a pretty pie chart, and it was just easy as pie, I would say. Okay, let's try number 2, or the next problem, which is having to do with illegal guns. So I put this one down here. I put our problems in different sheets. So this is in sheet 2. I put the problem. It says, a study by the U.S. Bureau of Alcohol, Tobacco, and Firearms surveyed 1,530 investigations by the U.S. BATF into illegal gun trafficking from July 1996 through December 1998. The study reports a portion of cases that result in each of the 5 gun trafficking violations. So we've got 46% straw purchase, 21% unlicensed sellers, 14% gun show and flea markets, 14% stolen from federally licensed dealers, 10% stolen from residences. And you're asked first to state the W's for this study to the extent that the story gives them. All right, and so you can actually insert a text box here so that we can write the answer. So I'm just going to make a little box so that I can just type the answer without having to worry that I'm in Excel. So the answer to A, let's see, we need to look at the who, the what, the where, the when, the why, and the how. So the who is, those are the cases. So it looks like illegal gun trafficking cases. And then the what? Well, they are measuring the type of violation, how they did it. And then the where, okay, it looks like the U.S. it's in the U.S. I'm thinking. Yes, so these are U.S. or the United States. And then the when, that's always the easy one because that's the date. So they say July 1996 to December 1998. Now sometimes they don't give you the date, so, but in this case they did. The why did they do that? Well, it's just a study by the U.S. Bureau of Alcohol and Tobacco and Firearms, so BATF. Okay, and then how did they do it? Well, they did a survey. So they surveyed 1,530 investigations. So that answers part A. Now part B, it says, what do you notice about the percentages listed and what does this probably mean? Okay, so maybe we better do some calculations on this to see what we have going on. So let me make my little chart. So this is going to be the case, and so the type of violation and the percent. And so we have straw purchase, and then we have unlicensed seller, gun shows and flea markets, and the stolen from federally licensed dealers, and then stolen from residences. Okay. And then again, you can see that it doesn't really fit in here very well. And one thing we can do is we can ask it to format it to fit. We can do auto fit column width. That's kind of fun. And so it's going to automatically fit for that stolen from federally licensed dealers. If I click that, notice how it made it just exactly the right. So that's kind of cool. Little trick in Excel. All right, now I'm going to go here and put my percents in. So I've got 46%, and then 21%, and then 14%, 14% again, and 10%. Okay, and so then I want to kind of take a look and see what the sum is and see if I'm over 100%. I kind of, in my head, I'm counting up and it looks like I might be. Remember, I can use this AutoSum feature to get it to sum, so I'll just come in here and I'll just say, give me the sum, and it selects the range, and that is the correct range, so I'll just hit enter, and I notice that it is 105%. So it must be that there's some overlapping, either that there was a straw purchase and unlicensed sellers or something like that. So when we come in here to answer part B to the question, what do you notice about the percentages listed, what does it mean? We'll say that they total more than 100%. Either a case may be assigned to more than one category, or one or more of the numbers are wrong. That could also be a case. That could be the case. Now, when you have over 100%, it doesn't make sense at all to use a pie chart. So what you're going to want to use is what's called a bar chart. And so that's part C, make a bar chart to display the results. So what you'll do is you'll come in like this, and you'll highlight just your data, and then we'll go to Insert. And now the bar chart, this is kind of misleading, but really the column chart in Excel is a traditional bar chart that we're used to. And we'll pick this one, the first one. Now that's fine. I personally like it to have different colors because I think that's cool. And so what you can do is you just click on any bar, and then you do a, let's see, under Format. So here's how it says Chart Tools. Come up to Format, and then you can select, okay, I'm sorry, I clicked this little arrow right here to show some more, and then I'm going to go into Fill, and I'm going to vary colors by point. If I do that, it's kind of cool because then it makes them different colors, so it's kind of pretty if you look at it like that. So Excel's fun, and it makes your data look really fancy and pretty, so that's kind of a nice problem. Okay, so let's go back to the lecture for a minute, and we're going to talk about some other types of data that we can, other ways that we can look at data. Okay, so we did the plane crashes, we did the illegal guns. Now, another thing that you may have data presented is in something called a contingency table, and it allows us to look at two categorical variables together, and it shows us how individuals are distributed along each variable contingent on the value of the other variable. The margins of the table, both on the right and on the bottom, give totals and the frequency distributions for each of the variables. So this one, the margins aren't, this is a contingency table, but the margins aren't filled out. If you total or summed these numbers right here, that would give you, that sum would give you the total for the number of people in the survey that had low blood pressure. If you summed this column, that would be the number of people that were under 30. So that's what they're talking about. And so what we're looking at here is we have low blood pressure contingent upon their different ages. You know, if you're under 30, how many? If you're between 30 and 49, how many? If you're over 50, how many? So each frequency distribution is called a marginal distribution of its respective variable. And each cell of the table gives the count for a combination of values of the two variables. So like the 48 is under 30 and normal blood pressure. Okay. A conditional distribution shows the distribution of one variable for just the individuals who satisfy some condition on another. So we'll look at that a little bit more carefully. And a fun bar chart to use when you have a conditional a contingency table is called the segmented bar chart, and it displays the same information as a pie chart but in the form of bars instead of circles, and it shows the segments. So that's really really cool because it shows the breakdown. Okay, so let's go ahead and work this problem. So we'll go back into Excel, and I had this one in sheet 3. Okay, and so what we're going to have to do is enter our data in. So what we'll do is we'll look at, I'll go ahead and put in, just redo this chart. So under 30, and then 30 to 49, and then over 50, and then we'll come in here and we'll go low, normal, and high. And then we'll put our data values in. So we've got 27, 48, 23, and then 37, 91, and 51, and then 31, 93, and 73. Okay, and I'm going to go ahead and get my totals, my marginal totals. So I'll do this way, and then I'll get my totals down here as well, just for thinking. Okay, so if you want to get the sum of these numbers, what you do is you come into AutoSum, and do sum, and it automatically knew that I wanted to sum those, and so I'll say enter. Now, there's two ways to get, you can do that each time for each of these columns, or notice now that this is a plus sign that's kind of fat. If you move it right over the corner of this cell and it becomes a dark plus sign, now if I push down the left mouse button and hold it and then drag, it's going to automatically fill the formula into each of the corresponding cells. So if I click on this cell, notice up here in the formula bar, I see that it has sum K7 to K9, which is right because there's K7 to K9, so it's adding it up. All right, now to get the sum here for this row, I'm going to go to AutoSum and just click AutoSum, and it did it for me correctly, so I'll hit enter, and then I will get, I like to call this dark plus sign, I like to call it the mommy. The big fat one's a daddy, so I'm going to grab the mommy, I'm going to pull it down, and notice this number 147, it is the sum of this column, but it's also the sum of this row because that's the total number of participants that were in the survey. Okay, so now it says find the marginal distribution of blood pressure. So what we want to know then is we want to look just at the margin of, imagine that we were sort of ignoring this divvying up of the under 30, 30 to 49, and 30 to 50, okay? So there's a couple ways to do this, but what you can do is you can just select this cell right here, and we'll just copy it. So if you go under right here to copy, you can say copy, and put it right here, and we'll just say paste. And then these numbers, the problem with this, if we try to copy these numbers right here, watch what happens. If you copy these numbers, it's going to actually copy the formulas. And so it's going to be summing, it's trying to think for you, so it's summing some weird values. So we don't want to do that. So if we just want to get those numbers, we can I'm just going to retype them. There's probably a snazzy way to get to copy just the numbers, and I will find that out for you. But for right now, I'm just going to retype them. So the 95, 232, 147, and then the total. Then you can do that with the AutoSum if you want, or you can actually, type it in from right there. Okay, and so now, if those are the totals, now to get the percent, because this is the marginal distribution of blood pressure, you want to look at both the totals and the percent, we will calculate the percent. And so this is going to be part over total times 100. So I'm going to put, in order to make it do that calculation, I'm going to do the equal sign to activate the formula bar. So I do the equal sign, and then I say take the number that's low, the 95, and divide that by the total, which is 474, and then I'm going to multiply that by 100 times 100. Okay? Now, before I move on, I'm going to try and get Excel to do this for me for each of the following, for the normal and for the high. And so each time I'm going to, like for normal, I'm going to want to do 232 divided by 474. So I'm always going to want to use this cell that's in J16. But if I try to grab the mommy and just pull down, it's going to increment this J16 just like it increments the J13. So like, let me just show you what I mean. Okay, so if I hit enter, that's fine, that works. But if I pull down to fill it down, it doesn't like that, because notice in the formula bar it did J14, which is right, that's the number I wanted, but it divided by J17 because it went down 1, 2, and I want it to divide by J16. So what I want to do is I want to make this J16 an absolute reference. I always want to only be talking about J16. And the way I can do that is by hitting the F4 button when I have the cursor placed in front of the cell that I want to make absolute. If I hit the F4, notice it puts dollar signs in front of the J and dollar sign in front of the 16. That means it's going to be an absolute reference. So you can do that with the F4s, or you can just actually type those dollar signs in. Okay, now notice when I pull this down, see how it fills them in? And it does it correctly. It does 232 out of 474, 147 out of 474. Okay? And then I could even bring it right down here, and I should expect it to be 100%, which it is right there. Now, on your online homework, they may want this rounded to 1 decimal place. And so if you don't want to have to think, you can come up here to the number, and you can decrease the number of decimals that you see. So I can just decrease this all the way down. And I can do that. I might highlight all of them so that it fits and does exactly the number of decimals that does it correctly to the right number of decimal places. Okay, so this is the marginal distribution of blood pressure. That's what I found right there that's part A. All right, now what do we want? B, find the conditional distribution of blood pressure within the conditional distribution of blood pressure level within each age group. So I'm going to actually have 3 charts now looking at the under 30 and that percentage, the 30-49, that percentage, and the over 50 percentage. So I am going to steal these words right here, the low, normal, high, total, Control C, and I'm going to put it right here. So this is going to be my answer to part B. All right, so I've got the low, normal, high, and I want to look at first the under 30. So I'm going to take these numbers right here. I'm going to pop them right in there. So that's one table, and I want to get the percents here, the percents, in order to find the conditional distribution for people under 30. So remember, a percent is a part out of total. So I'm going to do 27 out of 98 and then times 100. So I'll come up to my formula bar. I'll do equals. Then I'll do what is in J20, this cell, divided by this cell, and then times 100%, or times 100 to make it a percent. Now, I'm going to want to fill down with this cell, and so I want to make the J23 a fixed or absolute reference. So I move my cursor to right in front of the J23, and I hit the F4, and it makes an absolute reference, and I hit enter. So then now, if I want to fill this down, I can grab the mommy and pull it down. It might be time to show you that there is a fill down button right here, which I can do. Oops, that didn't work, did it? Let me undo that. I've never used the fill down. Let's see, I think you just highlight first. Well, there is a way to get it to fill down, but I'll have to play with that. I like to just grab the mommy and pull down. But notice here, what did it do? It did J21, which is this cell, and it divided it by J23. So 48 divided by 98. Now, if we want these numbers to be to 1 decimal place, we'll come up to the number and we'll decrease the decimal place down. So when we're typing it in on the online homework, we're not confused. Okay, so on part B, we have to do this. We have to repeat this for the, let's see, we have to do it for under 30, and then 30 to 49, and the over 50. So I'm just going to copy this chart right here. Let's see if I can. I'll just highlight the whole thing, Control C to copy it, or you can go up here to copy, and then I'm going to paste it, which I can do paste like that, and then I'm going to do it again right here. But I'm going to use the 30 to 49 values, so I'm going to do copy the 30 to 49, and then I'll paste them right here. So I'll do paste, and then I want to do the over 50, so I'm going to copy those, copy the over 50, and then come right in here and paste it right in there. So just paste. So those are the data values. Now I have to get my percents to work correctly. So what is this calculation going to be? Well, it seemed to know at least that I wanted to do J26, but I want to divide by J29 because that's the total there. So I'm going to come up here and just change this to a 9, J29, and hit enter. And then I'll come in here and get my mommy and drag it down to fill it out correctly. I know this is wrong because it should be 100%, right? Okay, let's see what's wrong with this one. All right, up in the formula bar, it's using N20, which is correct, but it's still using J23, and I need it to use N23, right? So I'll change this one to an N, and then hit enter, and then I'll drag down to fill it in for the rest of them. And so those are the conditional distributions of blood pressure level within each age group. So whether you're under 30, over 50, or between 30 and 49, those are my different conditional distributions. Now it says compare these distributions with a segmented bar graph. So this is kind of neat. On part C now, what we're going to do is we're going to go back up to our original data, and we're just going to highlight it, and then let me highlight it, and not the totals, just the original data without the totals. And then we'll go to insert, and then we will choose column, but we want a segmented bar chart, which is this second one here. And this is really neat because it kind of, let's see, you can just grab the chart and pull it over here to look at it. You can see that it's showing under 30, 30 to 49, and over 50, and showing whether they have high, normal, or low. And so now we can write a brief description of the association between age and blood pressure. Does there seem to be an association between age and blood pressure? Well, it sure seems that as age increases, the percent of adults with high blood pressure increases, right? It seems like there's more as age increases. Over 50, they have more of the green. And by the contrast, the percent adults with low blood pressure in the over 50 group, that seems to go down. So that's an observation that we can look at, which seems to show the association between age and blood pressure. So for part D then, we'll say, and we're going to want to write a text box. We're going to insert a text box so that we can get this to type in. Let's see. So I'm going to do text box. So I can type in the answer to D, which is, as age increases, the percent of adults with high blood pressure increases. And by contrast, the percent of adults with low blood pressure decreases. All right. Now, E, does this prove that people's blood pressure increases as they age? And the answer to that is no. Without a careful designed experiment, you can't say that just looking at this data that it proves that blood pressure increases with age. But it does give us an indication that it might be. We just are going to have to, there could be additional reasons that explain that besides the increase, besides age. So we can't make that statement that it proves it. So I'll type that in and kind of not have it in the video because that'll be boring. So I hope you feel a little bit better about Excel, and you're feeling a little bit better about understanding data now that you've watched this lecture. And so you're ready to start homework 1-1, where you'll be practicing these types of problems a few times. And let me show you, when you click in to homework 1-1, so let me see if I can just get to the homework. Let me get there real quickly. Okay, and so if I just come in here to homework, sorry, my computer doesn't want to give me, okay, so unit 1-1, I just wanted to show you one thing that's really cool. Like if you were going to work number 5 in the homework, it looks like it says the Center for Disease Control lists the cause of death in the United States during 1999. Each person is assigned only one cause of death, okay? And so they give you the different causes, and then they give you the percent. So let's work through this problem together. It says, is it reasonable to conclude that heart or respiratory disease were the cause of approximately 39% of the U.S. deaths in 1999? Now, as long as this adds up to 100%, can we say that heart and respiratory, let's see, respiratory disease is 7.7 and heart disease is 31.4, so around 39 does make sense. But we need to make sure that this percentage is correct and it doesn't add to over 100. So what you can do is you can click this button right here, click to copy table, and then you just do copy table to clipboard. So I'm just going to make the first choice. And then you say OK, and then you come into Excel, and let's get an Excel spreadsheet up. And I'm just going to do a new sheet, so I'm going to come in here, insert worksheet, so just come to a new sheet, and then I'm just going to paste. I'm going to click paste, and notice it filled it in for me. Now I'd like for this to fit better, so I'll come in here to format, and then I'm going to auto fit column width. Let me select all of them, and then format, and then auto fit column width. Well, that's all it's doing. Well, you can make it a little bigger if you want, like that. Okay, and now let's just check and make sure that this sums to 100%. So I'll come over to AutoSum, and then I'll hit enter, and oh, it's only 72.8. So it must be that this is not, there's some other reasons, there's other causes of death. So let's go to other, and let's make it other, and then right here we'll do 100 minus that sum. So just coming up and changing the formula bar to 100 minus, and then hit enter. And so now if we sum that, you should get to 100%. Okay. All right, so what does that tell you? If you just look at heart disease and respiratory disease, 31.4 and 7.7, that's about 39. So you can answer the question, is it reasonable to conclude that heart or respiratory disease were the cause of approximately 39% of the U.S. deaths in 1999? You can say yes, because there's no overlap. Because we only got, when we added up to 72, if we had added up to over 100, we would have to say no. So we'll say yes. Okay, now it says, what percent of deaths were from causes not listed here? And we already did that computation, right? We added those up and then did 100 minus that sum. So that was 27.2. And then we'll check our answer. Then it says select the diagram that represents these data. And this is fun because we can have Excel do a graph and then we can just compare them. So I'm going to select, just select the data, not the titles, cause of death and percent, and then go to insert and then do a pie chart. So there's your pie chart. Oops. Sorry, let me undo that. I always seem to grab the, I don't want to grab that. I want to grab the big chart like this. So move it over like that. And now let me look at my website and see which of those looks about the same. Which one would you guys pick? Looks to me like, oh, they're missing one here, aren't they? They don't have the other, so that's easy. That's kind of easy. So we can take that one off like that, and then we can check our answer. Okay. And so we got a green check, which means this problem's ready to go. If you wanted to practice it again, you could click on similar exercise. But for me, once I get the green check, I just kind of want to move on. Anyway, I hope you've enjoyed this lesson, and I'll talk to you again soon.